Okay, so today we're going to talk about defining functions. And in order to do this, what I'm going to do is I'm going to show a bunch of pictures, and we're going to put them into two categories of examples and non-examples. So let's take a look and see. Here is my first graph here. And at this point, you're not really going to be able to tell which one it is, and so I'm going to drag it over to here. It is an example of a function. When I look at the next graph as well, I know that this one here is also an example of what we call a function. Looking at this one here, I'm going to give you this one here is an example of a not a function. So these ones here are functions, these are not functions. So I want you to pause and think before I drag it over which one is going to be. Is it going to be part of the function category or non-function category? And if you guessed non-function, you are correct. Let's continue down. Here's another graph here. Think about, is it going to be part of a function or part of the non-function? This one is a function. Looking at this graph here, think about, is it going to be a function or non-function? You should be like trying to make some kind of a pattern. What is similar on the left side that's not in the right side? And this one here belongs on the function side. Looking at this sideways squiggle here, when we look at all these functions and non-functions, this is not a function. This one here is interesting. Which one do you think it's going to be? Take a moment, pause and think about that. If you said not a function, you are correct. Taking a look at this one here. Oh, one thing I should mention, the colors mean nothing. It was just me changing pens. All right, looking at this one here in the middle, think about, is it going to be function on this side or non-function? It belongs on the function side. This blue one here, function or non-function. Looking at all the ones you have, you should guess not a function. I think this is my last graph here is one, and you should guess this is a function. And so you're trying to generalize what makes a function and not a function. In order to help you, I'm going to take this red line. As I go across the function here from left to right, look how it touches onto the graph. And as I go over to this one here, the sideways squiggle one, the Z, it touches one place, two places, three places. Always more, sometimes more than one, so therefore this is not a function, whereas this only ever touches once. Moving down to the straight line here, diagonally here, it just touches once. Here it touches it once for a moment, then twice, and then once again. And so if I look at the blue graph here, this one only ever touches the graph one time. The sideways squiggle, well there it's once, but there it's more than once. And so you're looking for where does it touch more than once somewhere on the graph. You can see it touches twice. Here it touches once everywhere. And so on and so forth. Here it touches twice. And here it only touches once. So if you can take a vertical line and pass it through the graph from left to right, it only ever touches the graph once, that means it is a function. So to help you define this, if a graph passes the vertical line test, then it is a function. So all those lines, all these functions here passed what we call the vertical line test. And for every input value, there is only one output value. So if I take an x value, I plug it in, I only get one y value back. Whereas here, if I plug this x value in, I get a y value, a y value, and a y value. And that is your definition of a function.